Best of Educational Computing, a program devoted to the application of microcomputers in the educational environment. Today, we'll hear about teacher materials with Fred Ignazio and Karen Billings of Houghton Mifflin. Lydia Copeland will review Print Shop and Perception Games. And Ken Komoski will be giving us part 2 of his 3-part commentary on drill and practice software. Now, here's Lydia.
Our software for this segment is Perception Games by EduWare Services Incorporated. Perception Games presents 7 programs that illustrate various aspects of visual perception and that are aimed at improving the user's perception. The software comes in 3 versions, and we're going to look at the 3rd and most current version. Perception Games 3.0 is compatible with the Apple II, II Plus, and IIe computers, and the user must have either paddles or a joystick available to play many of the games. The package consists of a disc and an 11-page user's guide. The guide does not provide recommendations for instructional use, nor does it recommend a target audience. However, reviewers have suggested the package is appropriate for use in art, drafting, and math classrooms by students 10 years old and up. Perception Games provides practice in 4 areas of perception: length perception, shape recognition, size comparison, and hand-eye coordination. The length perception programs test the user's ability to match lengths of lines with one another. There are 5 different tests of length perception. The first one concerns 2 vertical lines standing on the floor of a room. The user is to attempt to match exactly the length of one line by manipulating the length of the other line with the paddle or joystick. And I'm going to do that right now. Let's see if I can make the line on the left approximately the same length as the right line. That looks pretty good. When she thinks she has evenly matched the lengths, she can press any key to see how she did. The scoreboard is shown after each attempt. Each scoreboard gives the user written feedback in a phrase such as, "This was a perfect match within 1%," and numerical feedback concerning the number of tries, the number of perfect, good, fair, and poor matches, and the percentages of each. The other games in length perception are matching the lengths of a horizontal and vertical line on a rear wall of a room, matching the lengths of crossing horizontal and vertical lines, 2 flags matched with a vertical line on the floor, a rather confusing game because without practice, the user doesn't know if he should match the distance between the flags or match the distance including the flags. The last game in length perception is matching a line on the left wall to one on the back wall. The shape recognition program tests the user's ability to remember the exact shape of a geometric figure. The player first sees the geometric figure through a falling window, which reveals only a part of the figure at a time. And we see that figure just disappearing now. And then the box goes on down to the bottom of the screen. After that, she is presented with 4 other figures, one of which is an exact replica of the test object previously seen through the falling window. And here come our 4 figures. And I believe that the correct one would be 2. The player selects one of the options, and again, the scoreboard provides immediate feedback. Right, the correct answer was 2. In this game, the player can set the level of difficulty by setting the number of lines which will compose the figure and by making adjustments in the degree of correspondence between the test figure and the 4 figures presented afterward. In the size comparison program, the player is asked to select the figure on the right of the screen that is the same size as the master figure on the left. Each figure on the right is displayed for a short period of time, from 1 second to 1/10 of a second, depending on the option set by the player. And the game can be made more or less difficult by setting other options. The last program, eye-hand coordination, consists of 4 games: Star Trace, Falling Line, Tilt Maze, and Visual Pursuit. However, unlike the other 3 programs, the eye-hand coordination games are not preceded by instructions on the computer screen, so they are confusing until you read the instructions in the user's guide. The first one is Star Trace. The task is to guide a dot in the space between two stars without hitting either star. The game is hard to play with any skill because the control the joystick or paddles provide is not adequate to the task. Centering a falling line is easier to play. The task here is to determine when the centers of two lines are aligned along a horizontal axis. In visual pursuit, a small box and a set of crosshairs are presented on the screen. The task is to use the paddles or joystick to move the hairs so that they intersect with the box before the box moves. Difficulty level is set by changing the size of the box and the number of tries in each attempt. The last game is Tilt Maze. It's the computerized version of the old hand game of trying to move a steel ball through a maze without it falling through holes. The difficulty of this game, like the others, can be set by the player. Unfortunately, as in Star Trace, the paddles or joystick don't give the player enough control to exercise any real skill. Perception Games is, however, highly recommended by its reviewers, despite the problems in some places with the lack of clear instructions and the difficulty with the use of the paddles or joystick. The programs present a set of fascinating skills, and students find the tasks interesting and challenging. Join me later for more software reviews.
I'm at the Houghton Mifflin booth with Karen Billings, an executive editor of the school division. Karen, what sort of computer materials are you working with at Houghton Mifflin?
We develop both computer books and computer software for schools, elementary and secondary schools.
I hear terms like computer literacy and integrating software and computers into the curriculum. You actually make materials to have that happen. Could you describe to us some of the things that you produce and where you would like to see them end up?
Well, for computer literacy, we produce both computer books and, again, some software, but for all grade levels. So it depends on what the school's goals are. Some of them are to, as you said, integrate computers into the curriculum. So we have some tools by which they can do that, the word processing, spreadsheets, database management systems, or the use of some computer books, computer literacy, programming books in BASIC, Logo, Pascal, any books where there are courses that are designed to teach some of those specific programming concepts.
Let's just say hypothetically now that you're put back into the classroom and you're just starting out, you don't know a thing about computers. Where would you start in terms of materials and first step? Because there's such a broad array of choices for the average teacher.
Well, I would go to a number of sources, but I would also probably go to two publishers who are producing a wide range of materials, who have had experience producing materials for those of us in the classroom.
With all the software available right now, what should a teacher look for? How can she sort out the good from the bad?
Well, I think the primary thing that I hear in terms of their concerns is that of how well it coordinates or connects to the curriculum that they're teaching. They're concerned about teaching certain skills or concepts or related objectives, then they want software that helps extend those.
There's a debate right now about how to use computers in the classroom. Should you teach about computers themselves, or should you use computers to teach about other things?
Well, I think we need to have both things happen. I think that, to me, the ideal thing is to have a computer teacher, say in a junior high, whose sole responsibility is to teach children some of the beginning concepts about computers, how computers work, vocabulary, terminology, to introduce them to what programming is all about, and to help them use software that people use in the outside world. Again, graphics programs, word processing, database managers, and spreadsheets are most often mentioned. Once the students have those tools and that understanding and access to that software, they can then use those in almost every course that they take for the rest of their junior high and high school career.
We hear a lot about software for kids. Is there anything out there for teachers?
Well, we have books, of course, written for teachers through the college division, of course, trade divisions, and, of course, teachers' editions of materials that we have, if you're talking about books. For software, we try and support the teacher's task in the classroom by giving that person more tools to work with. They have a lot of tasks that they have to do every day, such as scoring tests, such as making up tests, but the computer can help them. So we are doing a lot of test generators or test scoring software to save teachers time.
How about some advice for teachers who are just getting into computers? Should they take a course on computers, or is there some materials that will allow them to get started on their own?
Well, we'd like to think they could learn from some of our materials, and I think they can. I think it depends on their goal. If they want to learn how computers work and what some of the fundamental concepts of computers are, they can get a great deal of this from the book. If they want to be teaching computer science courses and want to be extending computer applications a little more extensively, they're going to need a solid background because there is a great deal of content there.
Okay, we really have time for about one more question. I'd like to ask you, let's look into the future. And if you're now, and you do have the chance to talk to teachers, what is like one skill or a couple primary skills in terms of computers that teachers should concentrate on with their students?
Primary skills, I think, are specifically in computer use. And I think they should start with a little bit of programming skills, but I think then that they should work with software that helps their tasks, their everyday tasks with schoolwork, a bit easier and a bit less frustrating, and I think a lot more exciting.
This party invitation, this poster, and this letterhead are the products of the software we've chosen for today. They've all been generated by The Print Shop, a software package by Border Bund Software. The Print Shop is compatible with the Apple II Plus, 2E, 2C, and 3 computers, as well as with all models of the Atari and with the Commodore 64. The package is complete with a 27-page user guide, a shorter card of disk instructions, and a reference card that depicts the type fonts available and many of the graphics in the program. The graphics may be produced with a keyboard, but a joystick and a koala pad provide the user with more creative options. Of course, a dot matrix printer is required to actually print the designs. The Print Shop enables users to create and print their own greeting cards, posters, letterheads, and banners by combining pre-designed graphics, type fonts, and borders, or by generating their own pictures with the keyboard, joystick, or koala pad. To demonstrate the package, we want to show you how this party invitation was created. The first step is to select the greeting card option from the main menu, and then choose to design your own greeting card rather than selecting a ready-made card. The first element of design is the border for the front of the card. Our card will have the double line border, only the second one listed. Notice as we highlight each option that the border around the menu changes, graphically displaying the different options. We'll go back up and choose our double line. After we've selected our border, we need to choose a graphic for the front of our card. There are 3 methods to pick graphics by, and we're going to use the first one, by picture, because it lets us review the Print Shop's collection of graphics and patterns. By moving the highlighter up and down the list, we can see some of the graphics available. There's a stork, a graduate, pumpkin, menorah, a Christmas tree, a wreath. Our particular graphic, Notes, is on the 3rd menu presented, and after selecting it, we get to select the size we want it printed. We'll select the medium option for the front of our invitation. Selecting the graphic layout is the next job. We'll choose to design a custom layout. We'll center our notes by putting them in the number 3 position. The choice of a type font is next. There are 9 available, and as you go through the menu, each is shown at the bottom of the screen. There's Party, Block, Typewriter, Stencil. We'll choose the Party font for our invitation. We'll go back up, and there it is. The last thing we need to do for the front of our invitation is to type our message in. Our message is, you're invited for a night of song. So let's go ahead and do that. And we want it centered. So we'll go down here. And yes, we do want it centered. The next step is to go through the same process for the inside of the card. First, we choose a border. This time, let's choose stars. Then we select a graphic, a piano for the inside. Then we can pick the size we want our inside graphic printed. And since it's a grand piano, we're going to make it large. This takes us back to the font menu, and we'll choose Party again. Now we'll type our message, and the message is Saturday, October 2nd, 1985, 10 o'clock, I'm going to make that a colon, to 2 o'clock. RSVP. And we'll use the name Kim, Tracy. This time, we're not going to center it. Finally, we would print our greeting card. The procedures for creating banners, letterheads, and posters are basically the same as we've just seen. As you can imagine, the possibilities for different combinations are almost infinite. Unfortunately, however, the program doesn't allow the user to see the final product on the screen before printing. This is the major weakness in the software. The print shop has 2 other items on its menu we want to mention briefly. One is Screen Magic. One kaleidoscope option in Screen Magic provides the user with 11 different pulsating kaleidoscopes that can be frozen and printed out, either by themselves or with messages superimposed over them. Another kaleidoscope option is a continually changing series of geometric shapes, which can be frozen for use in various ways. Finally, we want to mention the graphic editor format. The graphic editor allows the user to draw his own graphics on the screen by moving the cursor with a keyboard, joystick, or koala pad. The user can draw any picture he wants, save it on another disk, and then use it on greeting cards, signs, or banners instead of using the pre-programmed graphics. The print shop is easy to use, is of high technical quality, and comes with well-written instructions. It can be used by children as young as 8 or 9 or by adults. It would be a welcome addition to any art class and certainly is versatile enough to be used throughout the school, home, or small business.
In earlier shows, we've looked at many of the educational applications for the computer language logo, and at the storm of debate and controversy that has surrounded logo ever since it left scientists' labs 5 years ago. This week, we'll go behind the scenes back into scientists' labs to get a glimpse of logo's future. We'll look at 3 products that may never make it to your classroom or home, but which have tremendous potential for education. The first language we'll look at is 3D Logo, developed by Hiroyoshi Goto of Uni Limited in Tokyo, Japan. Currently, 3D Logo only runs on Japanese computers, but plans are to introduce it to the U.S. sometime in the near future. If anything characterizes the current versions of Logo, it is the little triangular turtle that a child can program to move about on the computer screen. The turtle carries a pen, and as it moves, it draws pictures. 3D Logo takes us out of the flat two-dimensional turtle world into a rich new world with 3 dimensions, just like the real world. In 3D Logo, you can control an aerial turtle that darts about through 3-dimensional space like a rocket ship in Star Wars. A child can program the turtle to draw 3-dimensional objects of any shape or description. Then he can look at the object from any perspective. The result is like a computer movie that a child can create with simple programming commands. With a tool like this, children, for example, could build a house, then build a person, then walk that person into the house and see things through the person's eyes. Dance instructors could create dancers leaping and whirling through space. Coaches could create movies of games, strategies, and plays to help them teach their athletes. Then each athlete could watch the play from his or her perspective. Have you ever played with Lego building blocks? Wasn't it surprising the way you could combine simple Lego blocks the size of your fingernail into amazing and complex buildings, bridges, creatures, and machines? Today's children may someday get the opportunity to bring their Lego creations to life, thanks to the efforts of Mitch Resnick and Michael Loco at the Lego and Logo Project at MIT in Cambridge, Massachusetts. Children who visit their lab use procedures they write in a new, enhanced version of Logo to activate and control the tiny gears and motors in their Lego inventions.
Kids learn best when they're enjoying and motivated by the things that they're working on. And this is something that works both with Lego and Logo, and the two systems really complement each other. In some ways, they're very similar. Both Lego and Logo come as types of building blocks. The building blocks of Lego are sort of obvious. With Logo, it's the building blocks of writing procedures. And in both, kids are learning a basic underlying idea that from starting with a lot of simple building blocks, you can build complex and interesting things.
2 girls built an amusement park, and all of the environment was developed. When the kids build their own device, their interest in controlling it is pretty high, so there's a real motivation to jump on the computer and learn the procedures to do that.
While I was at MIT, I also talked with Hal Abelson and Andy DeSessa, 2 Logo developers who are changing the purpose of Logo. And they're doing it by inventing a new computer language called Boxer. When I first heard of Boxer, visions of boxers like Muhammad Ali, Sugar Ray Leonard, and Michael Spinks danced in my mind. I wondered, will boxers replace turtles on a child's computer screen? Well, I was wrong. The name Boxer comes from boxes that appear on the computer screen. You can open the boxes up, and for the first time, you can see and control everything going on inside the computer.
Well, Boxer is what we think of as the next Logo, although I think that the present Logo is quite serviceable for a pretty large number of years. But when you look beyond that and you think about the kinds of computers people will have in the 1990s, if you imagine opening up a computer and it working as an interactive book that's full of text and simulation programs and graphics, and then you imagine that a teacher should be able to sit down and write that book, essentially as teachers now make worksheets, you come to the conclusion that Logo simply is not powerful enough, not integrated enough, and not easy enough to approach for that to happen. And Boxer is meant to do that. It's an integrated computer system in which you can look at databases, in which you can edit text, in which you can move around graphics, and in which you can do the familiar kinds of Logo programming, but all put together in a much more powerful environment. And we think it's, on the one hand, more powerful than Logo, and on the other hand, simpler. Because I think we've learned a lot about designing languages since we made Logo, and we're trying to put that into Boxer.
Maybe the most fundamental value that we've tried to propagate with Logo and now with Boxer is what I call democratizing technology. We're trying to make computers and programming and all of this kind of technical stuff something that everybody can use. And one of our main goals with Boxer is to make it useful for teachers in their everyday jobs, so that they're not learning it just for their students, but for themselves as well.
In our peek into the future, we've seen a Logo which can take our children from a 2-dimensional world to a 3-dimensional world. We've seen a logo which can free them from the screen completely and return them to the world of real machines and real inventions. And now with Boxer, we've seen how logo is evolving from a teaching language for children into a powerful, all-purpose tool that could be useful to everyone. Our glimpse into the future may or may not come true, but it does show some thrilling possibilities on the logo frontier.
Last week, I commented on what I call the lowest common denominator approach to computer learning, the approach that uses the computer as an electronic workbook modeled on the traditional paper and pencil classroom workbook that reduces learning to the common denominator of multiple choice or fill-in-the-blank responding. I pointed out that this half-century-old workbook approach to learning had its origins in a misguided effort to put all learners, the most capable and the least capable, on an equal footing by requiring that all learners do only what the least able of them could do. This eventually resulted in what former Secretary of Education Terrell Bell calls the dumbing down approach to learning materials. Now, the good news is that not all schools are taking this dumbed-down lowest common denominator approach. But the bad news, which really is not news at all, is that in many schools, the use of more challenging uses of computers and the more interesting and innovative software is being limited to the more able students. And those students who have been judged less able are spending their time on computers using drill and practice software. Give the dumb kids the dumbed-down programs and let the smart kids have programs that will help them get even smarter. Now, of course, nobody says it just in those words, at least not in public. But as is so often the case, action speaks louder than words. Now, the justification for taking such action is, of course, that those kids need drill and practice because they haven't mastered basic skills. And until they do, they aren't able to benefit from more challenging types of computer use. Well, recent research is proving this reasoning is very wrong-headed, and it's doing a grave disservice to millions of learners and to education in general. Next time, I'll be talking about the implications of such research for improving learning for all students.
Funds for this program were provided in part by the Corporation for Public Broadcasting.